Welcome to Season 5 of the Prodcast, Google's podcast about site reliability engineering and production software. This season, we are continuing our theme of friends and trends. It's all about what's coming up in the SRE space, from new technology to modernizing processes. And of course, the most important part is the friends we made along the way. So happy listening, and may all your incidents be novel.
You missed a page from Telebot.
Hey everyone, welcome back to the Prodcast, Google's podcast on SRE and production software. I'm Matt Siegler, and today we have a lot of folks with us. Let's start with my co-host, Steve. Who are you?
I'm Steve, still. I still remain Steve. How's it going, Matt?
That's good. Thank you. Great. And also today we have two guests. Introduce yourselves, please.
Hi. Yes, my name is Felipe. I am a tech lead in the Gemini safety team, and I'm a jack of all trades, doing everything I can to help everyone, everywhere, all at once.
Nice.
I like that.
And I'm Parker. I'm a product manager working with Felipe on model level safety. So we work on the Gemini family of models, but also on some of our generative media models like VO and Nano Banana, or otherwise known as Gemini Flash Image Generation version 2.0, whatever it's called.
Let's stick with the banana one. That's a much better name.
Yeah, exactly.
Yeah, dang, that's a cool name.
And we work on basically ensuring that our models output content that is hopefully helpful to people and safe. And we collaborate with a lot of teams across Google to bring the models to users in all kinds of different product experiences.
All right, let's get right out of the gates some terminology, rather. What do you mean by safe? I think I know what that word means, but let's have our audience some clarity, like exactly.
That does not cause fires. Is that it?
Yep, that's right.
That's
Easy.
one definition.
Easy.
Yeah, I can take that. I think, so safe breaks down in a bunch of different ways for us. You know, probably the simplest to start with is we do have product policies that have been defined by our trust and safety teams about all kinds of content that we do not want our models to generate. These are things like the worst of the worst, which could be even illegal content around child safety type of things. Also dangerous content, so instructions for how to build bombs and do things like that. But also, depending on the modality, it can also be things like nudity or other kinds of image or videos that we...
Like diagrams on how to build bombs, that kind of stuff too.
These days, we're getting more into that territory where the models are now have a lot of more world knowledge than they once did.
Crazy.
But then also it has to do with sort of other dimensions of safety, which we call... So one category of safety that is very important even under certain regulations in Europe are what we call frontier safety. And this has to do with the ways in which models could be used to harm people in a sort of more fundamental way. That could be around cybersecurity risks, but also things like CBRN, which is a long acronym for chemical, biological, radiological, and nuclear weapons and related issues. So we have a whole framework around that, which is sort of our internal policy that we also have shared with the world called the Frontier Safety Framework that specs out that area of safety.
Yeah, I feel like safety in this new world it quite changed from the place I was before. So like I spent a long time in search ranking. And at that point, it was much easier to define the boundary of what is working on safety versus what is working on ranking and quality. And it was somewhat deterministic, and the lines were well defined, like, you know, what you want to show, what you can show, what you cannot show. And the interaction between the user and the machine and your product, it was well defined. But now I feel like with those models, the interaction is open-ended and unbounded, right? So then like the safety definition becomes very squishy and a continuum. So what do you call safety? What do you call quality of the model? Is a model that is sycophantic? Is it a safety issue? Is it a quality issue? And I think like right now, that's why I said like I'm a jack of all trades, because like I'm not working only on safety. When you work on safety, you work on everything. So it touches so many aspects of the model that it's hard for you to define with few words. This is what safety is. And it's also not something that you know when you see. It's not like that. Like you really have to have some experience and have other people show you. It's not something you just get it. It's quite squishy in some ways, you know.
And it's a polarizing topic too. I'll just add, Steve, that a lot of people, some of the loudest voices on the internet, would prefer models that are maximally free to use, meaning like, they don't quote unquote censor or sort of they follow instructions to the T. So there's a tension there between.
So I can see how this very quickly gets away from a research program where, like we have these, how do we even stop it from doing X or Y? And it gets pretty quickly into product decisions, which is, I'm guessing, why Parker's here. And then my other question about how this works in terms of safety for sort of consumers is like, there's like billions of them and like we're in production and it's no longer research, like it's out in the world. Like we've moved from research into production. So just to remind ourselves, this is an SRE adjacent podcast. And so this is, I think, where it gets real funny or really tricky is like, so in the research world, we can, or like in the lab, we can say, we can kind of like hamper down certain types of responses. But how does it change when it gets into production? Like, how do we know it's actually working? Like, how do we know that the quality is actually at whatever bar it is that we want, whether it's safety or other measures of quality for the end users, like every day and like next week and the week after that and the week after that? Like what's the work that goes into making sure that the production user-facing system actually continues to hit these? Once we've drawn the line for safety, how do we know we're actually hitting it over time? That seems really, really hard to me.
Yeah, I feel like this is the classic, changing the wheel while the bus is running.
Yeah.
Because really, like, you really cannot predict all possible failure modes because of this fact I said before, where like everything is, so much of it is subjective and squishy, where the lines have to be drawn as you see new things happening. So you might decide that the model is not behaving the way that you wanted, that you decided that this is unaligned with what you want, and then you have to fix the model on the fly. And can you then predict and check for all possible dimensions and all possibilities of how the model will fail beforehand? We try, right? We try to have as much, benchmarks and as much evals as we can, but there's always this constant watching after the fact as well, if the model is behaving how we want. And that's where I think the research goes, because like it puts the researchers right at the line of duty where like you have to be there at the frontiers, watching the model behave and fixing the model as it goes as fast as possible, as opposed to the way that research used to be, where like you have plenty of time to test things out and then run, experiments on your back end and then wait. And then a week later, you get some interesting paper out of it. But this brings also like this problem of the loop as you see new things happening, you try to fix them, and then something else happened because you tried to fix, and so on and so forth. So like being able to do all of this, the entire loop very, very quickly is part of, it's part of my job. It's part of what me and Parker does, is designing and putting in place the systems that enables us to react so quickly and fix things on the fly like this.
I'll just add a little bit. I mean, to some extent, there's all of the classic approaches to trying to keep a pulse on how users are experiencing the product. So there's in-product user feedback, so people can do the thumbs down thing and give us feedback via comments. Obviously, we also keep a keen eye on social media and what people are sharing about the models and their experiences with products that use the models. But those are really just very partial glimpse into what people are actually experiencing. And what Felipe is saying is absolutely right. I mean, think about the Gemini app or, a ChatGPT type of experience where people are doing all sorts of different things, right? It's a very general purpose tool. And they can have very, very long conversations, which even if you were to look into the logs and try to understand them, there's a lot of additional context there around, across multiple sessions with a user. So it's a really tricky problem of how to monitor these systems effectively, even for known risks, much less sort of new risks that might be coming up that we're not as aware of, sort of out of the box. I do want to say, I just plus one to what Felipe was saying, like before we launch a new model, we do as much offline testing as we can, including what we sort of affectionately call ART, so automated red teaming, where you're sort of looking sort of more in a more exploratory way at all the different ways in which the model might react to different kinds of inputs. Some of it adversarial, intentionally trying to jailbreak the model in different ways. Others just more benign, just sort of trying to mimic real, good faith users, and just seeing how the model responds. Because a lot of this is just what Felipe said, the fact that the output space is infinite here and input space as well. How do you explore that in a way that hopefully gets to the most egregious stuff before you even put these things out? So there's a lot of work that we try to do in that.
Well, hope is not a strategy. I think we keep saying here, and I want to go a little bit back to something Steve called out, which is and then you guys have echoed, which is researchers and SREs are getting ever closer to working in concert in ways here that they've never before, which is, to me, like a very personally exciting thing. And I think you and I, Parker, have personally worked together in this for many years. And I think this is now becoming fruitful. And I'd like to ask you to reflect upon what is like novel tooling that you can speak about that's happening, that is noteworthy, that is not just shopping carts don't work. That is happening here. We have something going on where we're deploying a suite of tools that are being used by people, and they're used by people, and we want them to work well, and we need feedback loops for when they misbehave or do things we don't want them to do, that we can feedback and go alert and do, no, we don't like the quality we're showing to these people. We'd like to make quick changes. We have something go red, and then someone wakes up and goes, yep, we need to do something, or something automatically happens, and we make a quick intervention, and we quickly change something, rather than going back to a workbench on a researcher's desk, and they come in on a Monday and go, oh yeah, we need to quickly tune and deploy a new version. So something new is happening. Talk about how that something new is actually doing something faster than over iterations of weeks or months or quarters or, cycles of journals.
Yeah. I think we can speak about like the whole spectrum of like fixing a model on the fly like this. And sometimes it's not on the fly because it's a model. It's like, it's really hard to train. It takes a long time to train. Even after, it's fully trained, you can do certain kinds of tail patch post training and get the model fixed in that particular issue that you have. Even just the tail patch post training, which is like a very small iteration on top of the post training that already happened, it still takes like weeks, right? So it's not something, not because of the time of the training, but just the time of designing the steps that you have to do for training, creating data sets, and then running the GPUs, and then deploying the model. Even deploying the model, releasing the binary, takes several hours or days depending on which model. So that's like, it's not feasible to do that very quickly, but that's one side of the spectrum. And on the other side is a super dumb strategy where you just like match the exact query of the user. So if the user is found like a jailbreak, and you just like match the exact jailbreak, the classic, then kind of jailbreak. And you can do that. That's very brittle, kind of dumb. It will work only for that exact phrasing and but it's very quick. It's very quick for us to deploy and just block it, right? But what it goes in the middle is like where it gets interesting. And that's where like a lot of the innovation has been happening in the past couple of years. And those tools that we have right now to try to fix the model on the fly without having to do the full retraining and do only train on very specific slices of the model. That's where like most of the innovation happens. Of course, I'm not going to be able to speak of all the details because a lot of it is IP from GDM, but there is very interesting things that we've been developing so far that can be done very surgically, changes to either knowledge of the model or understanding of larger issues that the model has. And the model can self-monitor. So the model will know like that this is, I now understand, I've been told that this is dangerous and I have to steer away, or I have to behave in a different way for this particular kind of query, or for this particular topic, or for this particular response that I generate. And you can do that in a shorter time frame. It's not like weeks, but it's also not like a couple of minutes like you do in a regular expression, right? Like matching the query. It takes like a couple of hours for us to do this like type of training, and deploy it takes another couple of hours, but it's at least, a middle ground where you can react quickly and then change that type of behavior. And it's also a little bit more, way more flexible and non-brittle, where the model has the understanding of its own thoughts and it can react for different types of inputs. It's not just like
Right.
matching a single input.
It kind of reminds me, maybe tell me if I'm getting this wrong, but it kind of reminds me of like early DOS protection. It was like, let's just look for this exact string. And like that worked for some things. And then later we sort of developed these better algorithms where it was a lot more about more subtle signals and like looking at like broader concept. Like it's not the same actual system, obviously, but like, we started with the very direct things and then we got sort of to that chewy middle, and that's where the real fun is.
I'll just add two minor things on top of what Felipe said. But really practically speaking, for any company, that is deploying these models and wants to have an initial toolkit of what to do about safety, I think you need to think about system instructions or developer instructions, which is basically instructions that you give the model about what your definition of safe means, right? And that will help the model understand, like, this is one of, in addition to, giving the model a persona and explain what is the model actually doing for the user in whatever context is being deployed. You may have some safety guidelines, right? Which is to say, look at the query, think about these things. And if it goes against these rules, either respond in this way or don't respond at all, however you want them to do that, right? Like, think about what those should be. And those can be updated at any time, like really cheaply, right? Now, of course, not every model follows every instruction to the T. So it's not 100% guaranteed as an enforcement technique. The other thing is just classic filters, right? Like things that you can a lot of companies obviously already have content moderation filters that they can repurpose for Gen AI products. The other approach is just to take other LLMs and use them as a prompted classifier, which is very, very common these days, which is just to say, ask Gemini or your model of choice, like, is this piece of content that I'm showing you right now, does it violate one of these rules? If so, we will not show it to the user, that kind of thing. Like, those are two very, very practical and frankly sort of easy things to do that can be updated more or less on the fly, adjusting what the filters can do. And that's leveraging LLMs to do the work. Now, of course, second order and third order questions about, like, can these things be jailbroken? Yes, these are all risks. And this is where we're dealing with, it's going to be an arms race effectively, trying to get to better and better protections.
So while your teams are doing things like this, where you're, setting up like defensive structures and filtering and retraining, and then also having other LLMs come in and sort of like, hey, was that good in this way, in this particular definition of good before it like makes its way out? So it's like, it feels like a multi-layered defense kind of scenario, which is great. This tends to work when we have like not just like a hard shell, but like many layers of things when it comes to defensive systems. I have a question about that. Like, if you're all doing all that, and that's great, should users of these systems also be adding more layers, right? Should they be on top of that saying like, yo, LLM, I want to build this app which does this creative thing and then comes up with something else. By the way, layer. Like, so my question is, like, if an SRE out in the world who's listening to this wants to use an LLM for something and they don't want to delete the root file system of a production cluster, for example, like, I'm not sure that's going to be in your training data. Like, remember, never suggest that we delete the root file system off of a production system. What's some advice to someone who's out there who is trying to use an LLM to generate, code or systems or something on their system, right? It's sort of like a weird circular question, I guess. But like, I think this is on the topic of a lot of SREs' minds these days of like, I want to generate a bunch of code to help me do my job, but oh God, it's a little scary. What do we do to make sure the system itself is, like, the LLM itself is safe, but also the thing that it's guarding or building or fixing, like, Acme Corp, service.com, that thing stays safe also. Is that something that you guys think about or that you give advice about?
Yeah, I think like every once in a while I speak to the folks in cloud that are dealing with the clients. And this touches the problem of alignment. Alignment is not a constant. It is different between person to person, between company to company, between industries, governments, and so on. So like, if you have a different client, if your client is, for example, like a hospital and you're doing certain kinds of queries that are, deep questions about medicine and how to do certain kinds of procedures that you might not want to show that to a regular user or an underage user, you don't know, right? But for that client, you should, right? So that's like, you can have different kinds of policies. And some other clients might have even higher restrictions. If you're like a game developer and you want to show this to underage users, then you have to have like different guidelines there. So far, the types of systems that are available for the clients are they're still maturing, right? Like the kinds of systems are the ones that Parker already enumerated, which are somewhat either brittle or not 100% reliable, right? Which is, you write a system instruction and just pray for the model, please don't do something stupid here, which works most of the time, not 100% of the time. And that's the problem, right? So as things mature, I feel like we will see more and more those other kinds of systems where even the clients have access to and do a sliver of training on the model just to show this is the stuff that you need to pay attention to. And if you are deep into the weeds there, if you're good as a developer and you have like AI engineers working for your company there, you can get that done by using open source models and then doing some sort of post training on top of it, or using LoRa's or other techniques. But it gets complicated and hard to maintain very quickly, right? Every time you have to do for a new model, you're going to have to do the whole pipeline again. So maintenance and long-term updatability, right, is a big concern. And I think that with those other kinds of systems that you're training a model, it gets expensive and high maintenance very quickly. So that's why I feel like it's still in its infancy. I think there is a lot for us to do there. We're improving long-term maintainability and cost of maintenance there.
I'm going to add a couple of things. One thing is for SREs, because I think this community is amazing at this, is thinking about all the ways things might go wrong and designing smoke tests, like at both the model level and at the product end-to-end level of like even a few queries that are really targeted at things that if they go wrong, we're in a bad place and run those every time. You know what I mean? Like have your own, these things are often affectionately called vibe tests. People are checking for all kinds of vibes, security vibes, safety vibes, quality vibes, good feels, humor, all these things, right? And I think SRE just like has people who are just amazing at imagining all of the different ways in which this could go sideways. The other thing that I think is really important is I think SREs need to have visibility into the, for lack of a better term, like all the traces, like what is actually being shown to the model. Because a lot of the times people don't realize how complicated that gets in a production system, that we're layering on lots of different instructions, lots of different contexts being pulled in from all these different data sources, which could confuse and distract the model, lead it to a weird edge cases. And so having that observability, which I think is, again, like a very deep SRE principle of like, can we actually see from the model's point of view what it is being instructed to do and help potentially, root cause issues that might be caused by this weird composition of the context window, which is essentially, that is the model's entire world. It knows nothing that is not in that context window because these are not continuously trained, systems. So I think having that observability, having the SREs be a participant in thinking through what is a rational context to give the model for the purposes and to avoid a situation where the model is being asked to do two opposite things, which I think in certain situations that happens unintentionally, where you have multiple people contributing parts of the instructions or the SIs. Yeah.
Can I throw out a phrase I learned like the other day, which is drift detection? I think I understand this a little bit, maybe, I don't know. But basically like we think it's doing the right thing for a while. And then later we're like, oh God, it's not doing the thing anymore. What's happening? And this isn't necessarily about safety. Sometimes it's just like alignment with your company's, economic desires or something like that. Or just like, are we actually helping the customer with foo? Is this a term that people should be aware of? And do they need to be defensive about it? Or do they just wait for the foundational models to become perfect? Like, what do you think?
I mean, drift detection is like that concept. ML ops, I'm laughing because Matt and I were talking about this like 10 years ago.
Yeah, it's not new.
It's not a new concept, but no. But in a good way, in the sense that like, yes, you should be monitoring as much as you can. It's challenging to do so. But for example, if you have filters in place, you should be monitoring the rate of those filters, right? And you should probably be sampling some of the examples and looking at, the filter is just a classifier. So just do your confusion matrix. Like, what is the false positive rate on this classifier? What is the true positive rate? How can we continuously improve that part of the system? And that's one sort of fuzzy drift detection mechanism, Steve, right? Like if your filter rate all of a sudden like pops from 5 to 10% or whatever it is, like you're probably something has changed or so those kinds of principles absolutely apply.
Thank you for calling out the character traits that we think are particularly well suited to being scrutinous of quality. It's only recently that we now have something like rapidly being used in production by billions of people at scale, which is suitable for this work. Like until recently, it was novelty. It didn't have outcomes that were, valuable enough to bother pointing SREs at, but here we are. And I think ML SRE is it's about to have its kind of golden era, but I'd like to see the transferable skills actually transfer, but we're just sort of inventing something new. And it's kind of ill-defined. But we just called a second ago about what is DevOps when, ML code from the brain of the organism is generating. And you're like, well, how are we going to review this stuff? And how are we going to launch this stuff? And how are we going to iterate on this stuff? And then how are we going to review its propositions? And it's weird and wild and new. But I do think the same principles apply, which is alignment with the objectives of our users, having really strong values. And I don't think that's not new at all. That's the stuff that we've been doing for 20 years. So awesome. But I think a lot of our audience is curious about how they're going to do what they're doing right now, which is keeping shopping carts working to doing what you just described. So do you have any ideas how they can even get going? Like they're out there doing that. They want to be doing what you're talking about, and there's got to get there from here. Thoughts?
Yeah, I think there's what's happening right now in the present and what I think is going to happen in the future, right? Like I was just reading this blog post from Less Wrong recently, and they were talking about how improvements on everything, including AI, usually happens in step-by-step mode, in somewhat not linear, but somewhat incrementally over the time. But the perceived quality, the perceived usefulness is a step function where suddenly becomes useful. It's because when you get to that threshold of I cannot trust my AI to write the code for me because I have to check every line of my AI agent. That's, because there is a 20% chance that it's going to use a horrible bug in one of the lines. So I have to check every line, right? So that's not useful, right? So I'm going to have to spend as much time checking as I would have spent writing the code myself. But then suddenly, if that becomes a much lower probability that a horrible bug is going to be introduced in any given line, then I'm going to maybe not check every line anymore, and it's going to become useful. So that step happens all of a sudden while the AI has been improving, over time. And in the present, we're still in the middle of this. I think we're close to that step function, but we're still in the middle of this where I have to check the code, right?
Right.
And the problem that is happening right now is that, it is really easy to write a lot of code, way more code than I ever wrote my whole life.
Yep.
And that's true for all of the engineers, and it's true for people who are not engineers, and it's true for people that never touched, an IDE before. So what's happening right now in the present is we have a lot more code being produced, and still the same amount of people who are experienced as code reviewers, right? So what this means is that we are probably introducing a lot more code, a lot more bugs, everywhere in all of our systems if you're not reviewing them. So what do? You just hire a bunch of code reviewers, more, than the SREs that you're firing because AI is replacing them. I don't think that's, necessarily what should happen, right? But I do agree with that point on the blog post. I don't agree with the whole post, but I agree in that point of I think in the future we will cross the line where it becomes reliable to the point that you will not necessarily have to review all of the code. But meanwhile, it should work like a factory where every step of the factory you have to have a quality control. You don't have a quality control only on the end. You do at every step that is important. And this could be code reviews. This could be monitoring. This could be automated monitoring. This could be automated monitoring on your network to see if there's a new unforeseen activity that shouldn't be there. And that might mean that a new bug was introduced or something, right? So I think right now at the present, we still need this type of checks that you guys were mentioning and Parker was mentioning before as well.
I mean, the only thing I can say is I always love working with SREs because I think the pressure to ship fast is everywhere right now. For all the reasons Felipe just said too, it's easier than ever to just throw together a new product. I mean, look at how quickly OpenAI built, which was it? They were 6 weeks to build this massive new feature and shipped it. And with that comes an enormous amount of pressure on the teams who are actually responsible for maintaining it. And so I think to some extent, SRE's time to shine is here, both in terms of just keeping these new products up, but also managing these risks and not burying our heads in the sand until something explodes. So I don't know. I feel like There's also the question of how do you use these models as part of SRE, like to do your jobs better or more easily or faster or at more scale. I have no special knowledge about that one, but I think every single person right now is having to think through that question of like, how do I use these models? How much can I trust them to be a part of my core toolkit? And so I think that's a pretty exciting time to be doing this work.
Wow.
I also feel like we are the wrong kind of person to ask that kind of question, because we're always like or maybe we're the right people, right? Because we're always like thinking about what can possibly go wrong.
That's
like
true.
Thinking like, I think the models are doing stupid things right now. We have to fix them and they're not reliable. But if you ask other people, they're going to say, well, have you seen what happened the last 2 years? Like the models are really reliable right now, if you compare to 2 years ago. Yeah, okay. But there's still room to improvement.
Well, great. We're just about running out of time. I'd like to ask sort of open-ended questions, as we like to do with our guests sort of at the end of the episode. What's something that kind of concerns you about where we're going right now? Big picture, like either culturally within or within the industry, that we're not keeping our eyes on the ball about, that we need to really care about the value to make sure we work hard to that, but that we are using our forces to keep from doing so, that we do.
What's in the shadows? What's the scary part right now?
Yeah.
I mean, I think that the speed makes it very challenging to exercise foresight across the industry about where this is all going. And that is the thing that I think keeps me up at night, is how do we deal with the problems we have today and that have been created by things that have been shipped yesterday, while also proverbially skating to where the puck is likely to be and where we can probably tell it's going to be in 6 months. But just there are not enough hours in the day to be trying to solve the future problems and today's problems. I guess at Google and at DeepMind, we're spoiled in that we have research teams whose job it is to think ahead. But I think about that as an industry-wide challenge. Like I can imagine be doing a similar job at a company that doesn't have the kind of research bench that the labs do, trying to think about how to get ahead of these things. Whereas, when we were shipping at a slower pace, there was more opportunity to think about, how do you automate things that should be automated, and how do you do like more thorough checks before you launch. I also think that there's an element of education, for lack of a better word, around what risks are out there. There's a whole, the Twitter sphere, like, the AI safety Twitter, if you tune in, they're talking about all kinds of things that I think it would be hard to follow for somebody who's just trying to ship a great product, right? Like there's just such a long list, like depending on what kinds of models you're using, what modalities, like agentic and not agentic, and all just the permutations of all the things that could, in theory, go wrong. It's just there's no way to tune in and have a full sense of them. And so I'm curious, maybe it's less of a concern and more of a hope that, product people, SRE, all the engineering leadership will sort of take time to also learn about these things, and that we'll have a better shared vocabulary for how to communicate about these things. And just as an industry, realize that we are in it together. That's one of the wonderful things about SRE and safety. It's like, we have to get this right. Sorry, that's a little bit of a rah-rah.
Awesome. I knew you'd be optimistic, Parker. It's wonderful.
Yeah, I wanted to plus one on the pace of change, like the velocity that has been happening over the last couple of years. If you think about when I joined GDM and before that, when I was working on BARD and other stuff, we were quite separate between the team doing today's safety, like what the model is doing is something stupid today, versus the team that is doing the next level safety, the next model, the frontier safety. Like those were two separate teams. One is doing research, long-term story about what's going to happen in the future. The other is what we have to do right now to fix the stupid model that is doing something stupid today. And I feel like today, since 2 years ago, has changed so much that right now the two teams are working together because we are right there, very, very close to each other. And this is what actually, worries me, is that the pace of the evolution was so vast that the long-term research that we had to do, now we don't have enough time to do long-term research because we have to do that long-term research for the model is going to come up in 6 months, right? So you don't have 2 years to research. You have, a few months only. And by the time that model comes out, you have to be ready. You have to deploy all the ideas that you had. So that's why We are now living in a world where like engineering, deployment, and research is happening at the same time. And if we don't help each other, I'm not a researcher from my background, but I have to do research together with the researchers because I have to deploy things that are needed right now. And it's kind of scary because like we don't have enough time.
It's been great. Wow. Thank you so much. Really appreciate you giving your time today. It's been a wonderful episode. Thanks, Steve. Thank you, Felipe, Parker.
Thank you, guys.
Have a good one.
Great to talk.
Thank you.
You've been listening to the Prodcast, Google's podcast on site reliability engineering. Visit us on the web at sre.google, where you can find books, papers, workshops, videos, and more about SRE. This season is brought to you by our hosts, Jordan Greenberg, Steve McGhee, Florian Rathgeber, and Matt Siegler, with contributions from many SREs behind the scenes. The Prodcast is produced by Paul Guglielmino and Salim Virji. The Prodcast theme is Telebot by Javi Beltran and Jordan Greenberg.
You missed a page from Telebot.